Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have given idea about diazonium salts. Now I will tell in details of diazonium salts. I will discuss physical properties and chemical reaction. First, I will discuss physical properties. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold, but reacts with water when warmed. Again, I am repeating. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold, but reacts with water when warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is a water insoluble and stable at room temperature. Again, this point is important. I am repeating. Benzene diazonium fluoroborate. Benzene diazonium fluoroborate is a water insoluble and stable at room temperature. This question is asked. Now come to the chemical reaction. The reaction of diazonium salts can be broadly divided into two categories. First, a reaction involving displacement of nitrogen, and second, reaction involving reaction of diazo group. Di means two. Diazo group. Okay. Then reactions are divided into two categories. First, reactions involving displacement of nitrogen, and second, reaction involving retention of diazo group. Retention of diazo group. First reaction I am telling you means reactions involving displacement of nitrogen. Diazonium group, being a very good living group, is substituted by other groups such as Cl- means chloride ion, bromide ion, iodide ion, cyanide ion and OH ion, which displace nitrogen from the aromatic ring. The nitrogen formed escapes from the reaction mixture as gas. Okay, again listen. Diazonium group, being a very good living group, is substituted by other groups such as chloride, bromide, iodide, cyanide and hydroxyl group. These groups displace nitrogen from the aromatic ring. The nitrogen formed escapes from the reaction mixture as a gas. Now see the replacement by halide or cyanide ion. The chloride, bromide and cyanide nucleophiles, these are nucleophiles, can easily be introduced in the benzene ring in the presence of cuprous ion, means Cu1. Cu is oxidation state is 1. Means here the chloride ion, bromide ion and cyanide ion, these are the nucleophiles, can easily be introduced in the benzene ring in the presence of cuprous ion. This reaction is called Sand-Meyer reaction. Very, very important reaction. This reaction is called Sand-Meyer reaction. Means you are introducing chloride ion, bromide ion and cyanide ion. These are the nucleophiles. And can easily be introduced in the benzene ring in the presence of cuprous ion. This reaction is called Sand-Meyer reaction. Okay. Then now reaction I am telling you ArN2X. This benzene diazonium salt that is you can represent like ArN2X minus. Ar means phenyl group. Ar means phenyl group. N2X, that is actually azo group, diazo group. N2 has plus charge, X has minus charge. Then now in presence of, here you have to think that what are the condition. Then in the presence of CuCl and HCl, these are the condition. Three conditions are there. First condition I am telling you that ArN2X, N2 is positive charge, X is minus, because it is the salt that is called benzene diazonium chloride. Ar is considered as a benzene ring, means phenyl group. This is the example of diazonium salt. General way you can represent diazonium salt as Ar, aryl group, Ar N2X. N2 has positive charge, X has negative. Now in the presence of CuCl and HCl, it will give ArCl plus N2. Then here you see X is going to be substituted by Cl, because you are using CuCl in presence of HCl. Then bond Ar and all bond will break. Bond between Ar and N2. Ar and N2, that bond will break first, and N2 and X bond will also break. Two bond will break. Then N2 will be free. It will go as nitrogen gas. Okay. And that Cl from the CuCl, that Cl, that is the negatively charged CuCl, that Cl will be negatively charged, that will join with, that Cl minus will join with Ar positive. Ar positive, because N2 plus is there, that will go by taking the electron and it will become neutral, nitrogen gas, and Ar will become negative. Ar, here mechanism we have to understand that Ar N2X minus is there. Then N2 will go as a nitrogen gas, correct? And this N2 plus, that will take the electron. When bond will break, electron will be taken by N2. Then on N2 positive charge was there, that became neutral, N2. And because electron is taken by nitrogen, then Ar became positive. Ar, aryl group became positive. Then now Cl from CuCl, that Cl minus will come and join the Ar positive, aryl group, and it will form ArCl. Other product will be N2. Other product will be nitrogen gas. This is the first condition, correct? Here X minus Ar N2 X minus was there, that X you can consider as a Cl, correct? Now you can see second condition. that CuBr in presence of HBr, reaction will be the similar. Just like now in the place of Cl, you consider Br. All things will be the same. It will form ArBr plus N2. Third condition now see CuCN in presence of KCN. Then here again reaction will be the similar. In the place of X you consider Cn, because Cn is also minus. All are minus. Cl minus Br minus Cn minus. Cn is also cyanide ion is minus. Hence same reaction will take place. It will form ArCl, ArCN plus N2. Okay. Then this I have discussed replacement of halide. Replacement of halide or cyanide ion. Okay. Other method is also there, alternative. Chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. This reaction is referred as Gattermann reaction. Very, very important reaction. Question is asked in all examination, medical as well as engineering. Okay. Then this is the alternative method. Chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid in the presence of copper powder. This you remember the condition. Here copper you are taking, not the copper chloride. You are not taking cuprous chloride, CuCl. Here you are taking copper, solid metal, in presence of HCl. Here are two conditions. Both conditions I will tell. Then first Cu in presence of HCl. It will form same type of reaction. Means here again N2 gas will go. N2 will go as N2 gas. Ar N2 plus X minus there. Then N2 plus will go as N2. Same type of reaction. And here this already this there is Cl was there. Ar N2 X minus. Here X you can consider as a Cl, or you can consider CuHCl. There also Cl is there. Anyone you can consider. Then Cl minus will join the Ar and it will form ArCl, and other product will be N2 gas. Correct? And now copper you have used. Then what was the role of copper? Then this copper, now it will react. It will react with these things X minus. Correct? Which from the molecule Ar into X, that X gone, X minus, that will react with the copper and it will form CuX, cuprous chloride or cuprous halide. Okay, from the HCl, that Cl minus joined with Ar, it form ArCl plus nitrogen gas plus CuX. Second condition you remember, Cu in presence of HBr. Here you are using in the place of HCl HBr. Then obviously reaction will be similar. In the place of Cl, now you are using Br. There was a Cl in copper. Here again HBr and copper. Then here Ar will form ArBr. Br is introduced. Okay, ArBr plus N2 plus CuX. Correct? This reaction is called Gattermann reaction. Here in Gatterman reaction, main condition is that you are using copper metal, not the cuprous chloride, copper metal in presence of HCl or copper metal in presence of HBr as your requirement. If you want to introduce Cl, then use HCl. If you want to introduce bromine ion, then you can use HBr, but copper is common. The yield in Sand-Meyer reaction is found to be better than Gatterman reaction. Okay, in this case, you will compare Sand-Meyer reaction. You are comparing with Sand-Meyer reaction with Gatterman reaction. Then in comparison, after comparison, you will find, or it has been observed, seen, the yield in the Sand-Meyer reaction is found to be better than Gatterman reaction. Okay, question is asked. Okay, whose yield means production is more. Then Sand-Meyer reaction, by that way you will get AgCl or AgBr that will be better than Gatterman reaction. Second reaction I am telling you, second chemical reaction of diazonium salt. Replacement by iodide ion. Now see, I have discussed this chloride and bromide. Now iodide ion you separately you understand. Replacement by iodide ion. Iodine is not easily introduced into the benzene ring directly, but when diazonium salt solution is treated with potassium iodide, iodobenzene is formed. Actually, introduction of iodine in benzene is little difficult. Okay, then here you will take a Ki, no metal. Okay, potassium iodide you require here. ArN2Cl, N2 has plus charge, Cl minus. ArN2Cl plus Ki. Reaction is simple. Now iodide ion will be introduced with Ar. You will get Ari plus N2 plus KCl. Very simple reaction. Ki means K plus I minus. And here ArN2Cl, that is a Cl minus. Then K plus Cl minus. It will form KCl. Correct? And N2 will be released. And Ar will be, then that time Ar will become positive because electron will be taken by N2 plus. Then N2 will be neutral, nitrogen gas. And I, that is a negative charge, iodide ion, that will join with Ar positive. Correct? Hence you will get Ari, aryl. Ar means aryl iodide plus KCl plus N2. Now again you understand replacement by fluoride ion because its condition is different than chloride and bromide. Now fluoride I am telling you, replacement by fluoride ion. When arene diazonium chloride, that is you are talking about the diazonium salt, when that is also called arene diazonium chloride. When arene diazonium chloride is treated with fluoroboric acid, means HbF4, that is called fluoroboric acid. When arene diazonium chloride is treated with fluoroboric acid, arene diazonium fluoroborate is precipitated. What is precipitated? Arene diazonium fluoroborate is precipitated, which on heating decomposes to yield aryl fluoride. Finally, we will get aryl fluoride. Reaction you can see it is a two-step reaction. ArN2Cl, N2 is positive charge, Cl is negative, plus HbF4. Then here you have to understand HbF4. When HbF4 will break, it will give H plus and then BF4 minus. Two part, H plus BF4 minus. Okay. Then what will happen? Now we are understanding positive will go to the negative. Very simple way. Negative will go to the positive. H is positive charge. H is positive charge and BF4 is negative. Then here what will happen? That because Cl minus and here BF4 minus. HBF4 was there, H it broken, bond broken, then we got H plus BF4 minus. Then this BF4 minus will go in the place of Cl minus and Cl minus will come out. Then you will get Ar into BF4. Correct? Now BF4 has been introduced with N2. Ar into BF4, it is negative charge. Hence in the place of Cl minus, this came BrF4. This is the unstable. And Cl, where it will go Cl minus, then Cl minus will go with H plus and it will form HCl. Now, because this Ar into BF4 is unstable, then on heating it will decompose to yield aryl fluoride. Aryl fluoride means if you heat, then again same thing will happen, that Ar-N2 bond will break and N2 and BF4, that bond also will break. Then you will get ArF. One F, because Ar is positive and BF4 negative is there, then from that one out of 4F, one F will come out and it will join with Ar. Then you will get ArF and N2 is free. Then what is remaining? BF3 plus BF3. Correct? Boron trifluoride, BrF3, boron trifluoride. Okay. Then Ar-N2Cl plus HbF4, you will get first product, unstable product you will get Ar-N2BF4, and on heating you will get ArF plus BF3 plus N2. Now next I am telling replacement by H. Replacement by H, hydrogen. Certain mild reducing agents like hypophosphorus acid. Hypophosphorus acid is also called phosphinic acid. Correct? Mild reducing agents like hypophosphorus acid, which is also called phosphinic acid, or ethanol, reduce diazonium salt to arene and themselves get oxidized to phosphorus acid or ethanol, aldehyde. Correct? Then this is a important reaction. Again I am telling you, mild reducing agents like hypophosphorus acid or ethanol, anyone, reduce diazonium salt to arenes and themselves get oxidized to phosphorus acid. Means hypophosphorus acid is converting to phosphorus acid and ethanol, aldehyde, ethanol. Okay. Reaction I am telling you that Ar-N2Cl plus H3PO2, hypophosphoric acid, H3PO2 plus H2O, Ar-N2Cl, N2 is positive charge, Cl is negative, always remember, Ar-N2Cl plus H3PO2 plus H2O. Here like what I discussed, same way here AR N2 bond will break, N2 Cl bond also will break. Then here with AR, H will join. H2O, it will provide H plus and OH minus. Then now H will join the AR and it will form ARH, means directly you will get benzene, arene or benzene plus N2 plus H3PO3, H3PO, it was actually H3PO2, but now because it got oxidized, then H3PO2 now converted to H3PO3. Then one oxygen came from where? Then it came from H2O, correct? Then now it was H3PO2, now it became H3PO3, correct? Plus HCl, okay? Then all thing is balanced. You got phosphorus acid, H3PO3, okay? From hypophosphoric acid, phosphorus acid, you got from hypophosphorus acid, you got phosphorus acid, correct? Then here all things are balanced. H2O, I told you H2O, 2 H was there in H2O, then 1 H, it gone as H plus, correct? OH minus was there. That H plus gone with AR, it formed ARH, because AR was negative and H plus is positive. You got main product, correct? Arene or benzene, you can tell, plus N2 plus now Cl, where it will go? Cl required 1 H plus, because 1 H plus already you have used. H2O has 2 H, then 1 H gone as a H plus with AR, it formed ARH. Now Cl is minus, then it also required H plus, then now OH minus is there, then now H will again, it will leave as H plus and O will become 2 negative, then that H plus and Cl minus, that will form HCl, and now oxygen is 2 negative, that will join with H3PO2, it will form H3PO3. Phosphorus will take this electron, means bond will, it will make the bond, then 2 electron is required, then now oxygen has 2 electron, that can make the bond with phosphorus, correct? Then this oxygen can make bond with phosphorus, now it will become H3PO3. Now same way ethanol, with ethanol what we will get, I am telling you, ArN2 Cl minus, N2 plus Cl minus plus ethyl alcohol, means CH3 CH2 OH. Then here again you will get same way ARH means benzene you will get, or arene plus again N2 will be released, plus again you will get HCl, correct? And a new product, that is the aldehyde, you will get CH3CHO. Here you have to understand, I am explaining now. ARH will form, that you know, H plus will come to AR. One product you formed, you got ARH. Now bond broken, then N2 became neutral, it went as a nitrogen gas, 2 product.
Third product, you know that Cl minus is there, then it required H plus. Then now you can see one H plus you have used, then one more H plus is required. Then from where it will come? Then it will come from ethyl alcohol CH3CH2, OH is there. Then 2 hydrogen is there with CH2. Then from that this ethyl alcohol 2 hydrogen will come as H plus. Then obviously that carbon will become 2 negative. Correct? H is coming as H plus, 2H plus. Then one H plus gone with Ar and other H plus gone with Cl minus. HCl it formed. Correct? ARH also formed, N2 also formed. Then now think for this remaining molecule of ethanol. Then now this CH3 will be as it is, no disturbance. Only disturbance is in hydrogen. Then there it was there, CH3, CH2, OH was there. Then here 2H went out. Then now here what is remaining? It is remaining COH is remaining. COH is remaining. Correct? Then now you can understand COH is there. Then only and that carbon has I can say 2 electron. Carbon has 2 electron. How it came? Then H gone as only H plus. 2 hydrogen gone as H plus. Then oxygens are there. Then now what will happen? Now COH. OH. Then here what will happen? Just a rearrangement reaction will take place. Now COH, C and O, single bond is there. Single bond is there. Then here actually what will happen? That O and H, that bond will break. That bond will break. Okay. And then bond will break, then H will take, it will come H plus and oxygen will become negative. Correct? Then it can make a double bond. Now after breaking this bond OH, now O has negative charge. Now it will make a double bond with carbon. Correct? Then now this because carbon was having 2 electron. Correct? Then now oxygen also have now electron. Then anyway 2 electron can make double bond. Then now double bond is formed, C double bond O. Then now hydrogen is as a H plus. No electron is with him. No electron is with hydrogen. But on carbon 2 electron is there. Then to make one bond 2 electron is required. Then that 2 electron will be used. Hydrogen is there. Then it will make bond, single bond. Then now you got CH3 C double O H, H bond H, C and H. That is called CHO, aldehyde. Aldehyde also same structure, COH or CHO you can tell, C and H single bond. That in any way you will understand, then you will find that carbon hydrogen bond formed single bond and oxygen formed double bond. How it become double? I told you that if 2 electron is available on oxygen, it can form double bond. Correct? Hydrogen is H plus or carbon is negative charge. 2 electron is there. Then actually that 2 electron is there. One is of hydrogen only. correct? But taken because in comparison to hydrogen, carbon is electronegative, correct? Hence you can form the bond. Then you got aldehyde. Then ArN2Cl, ArN2 plus Cl minus plus ethyl alcohol. It will give ARH plus N2 plus acetaldehyde, CH3CHO plus HCl. Now I am telling you replacement by hydroxyl group. Replacement by hydroxyl group OH minus. If the temperature of the diazonium salt solution is allowed to rise up to 283 Kelvin, the salt gets hydrolyzed to phenol. Now OH is going to introduced. OH you are going to introduce to the aryl group, means AR. Then here automatically directly AR will attach to the OH because AR is positive, you know, OH is negative. In presence of H2O, H2O will give OH minus H plus. Then this OH minus will go to the plus, AR plus is there, AR OH is formed. This is called phenol. AR is phenyl group, C6H5, now OH is introduced. You got phenol plus N2 plus HCl, H plus of water and Cl minus. It will form HCl. Cl minus is from Ar2N2 Cl, correct? Then easily way you have introduced OH group to the aryl group. You got phenol. But temperature you have to rise up to 283 Kelvin, correct? Then salt gets hydrolyzed to phenol. Next reaction is replacement by NO2. Replacement by NO2. Here you should understand NO2 has positive charge. N has positive charge. Then NO2 group you want to introduce with benzene, aryl. When diazonium fluoroborate is heated with aqueous sodium nitrile solution, aqueous sodium nitrile, this aqueous solution sodium nitrite, not nitrile, nitrite, aqueous sodium nitrite solution in the presence of copper. In the presence of copper, the diazonium salt group is replaced by NO2. Here you should understand that it will be nitrated with fluoroboric acid. Okay, then already I discussed reaction with this ArN2Cl plus HbF4. I have discussed. HbF4 is fluoroboric acid. Then you will get N2BF4. Already I have discussed. Because Cl is minus and HbF4, then H plus, BF4 minus. Then in the place of Cl minus, another minus is going, BF4. Then you got now N2BF4. This is unstable. Now here main reaction is going on. Okay, I told you when diazonium fluoroborate, now you got diazonium fluoroborate. Now you are heating with NaNO2, aqueous solution of sodium nitrite. You are heating. Then what will happen? That complete this bond. N2 was attached to the benzene ring. N2BF4 was there. Then that bond, N2 and carbon bond, will break. And there, because N2 will go, N2BF4. Actually, that bond, that N2 and BF4, that bond will also break, and it will form N2, and BF4 is negative and NaNO2. Here NaNO2. Then Na will go as a Na plus, NO2 will become minus, NO2 minus. Okay. Here you are taking NaNO2, sodium nitrite. Then here nitrite NO2 will be negative. You are talking about here from this nitrate you are taking from NaNO2. Then here NO2 will be negative. Okay. Nitration time HNO3 and H2SO4, that time you are getting plus NO2. Okay. But here you will get, because directly you are taking NaNO2. You are not using HNO3 and H2SO4. If you will take that thing, then you will get plus NO2. But here you are taking NaNO2. Na will be plus, NO2 will be minus. Then this Na plus will go to the BF4 minus and it will form NaBF4. And N2 will go as nitrogen gas. Correct? Then here NO2 is negative. NO2 is negative and N2 has taken the electron that become negative, then carbon will become positive. Then positive carbon and negative NO2 both will make a bond. Then NO2 is introduced. You got nitrobenzene. Correct? Now next reaction I am telling you, that is the reaction involving retention of diazo group. Now you don't want to relieve diazo group. You want to protect diazo group. That type of reaction I am telling you, reactions involving retention of diazo group. That is also called retention of this diazo group. That is called coupling reactions. That is called coupling reaction. The azo products obtained have an extended conjugate system having both the aromatic rings joined through the N double bond. Here listen, the azo product, whatever product you will get, that is called azo product. The azo products obtained have an extended conjugate system. Conjugate system means double and single bond. Then product, whatever product you will get that have extended conjugate system having both the aromatic rings joined through N double bond. Then from end aromatic ring will join. These compounds are often colored and are used as dyes. DYES, dyes, colored. Okay, you will get this compound will be generally colored. Benzene diazonium chloride reacts with phenol in which the phenol molecules at its para position is coupled with diazonium salt to form para-hydroxy azobenzene. This reaction is very, very important. Again you listen. Benzene diazonium chloride, when react with phenols, benzene diazonium chloride reacts with phenol in which the phenol molecule at its para position is coupled with diazonium salt. Means phenol will react with diazonium salt. Phenol, OH role is there. Okay, phenol molecules, that is the benzene diazonium chloride reacts with phenol, in which phenol molecule at its para position is coupled with diazonium salt. And what will it form? It will form para-hydroxy azobenzene. This type of reaction is known as coupling reaction. very, very important reaction. Similarly, the reaction of diazonium salt with aniline yields means it will give the product, it will form the product para-amino-azobenzene. This is an example of electrophilic substitution reaction. Both reaction I am telling you, and it is very easy to write. Reaction is easy to write. Why it is easy to write? Because both molecule write that is this thing ArN2Cl minus. There you write phenol. Both are close. Then phenol OH group is there. Then all remaining carbon hydrogen is there. Then that hydrogen and Cl from N2Cl. ArN2Cl, that Cl and H of carbon, of phenol, H of phenol, both will react. HCl, it will go as a Cl, and that this NN bond will be there. It will not break. Okay. Then H plus and Cl minus, it will go as HCl. Correct? Now after that what will happen? Because H plus gone as H plus, then that carbon will become negative. And Cl went as minus, then that N will become positive. Then N positive and carbon negative both will join. You will get long compound because phenol is joined with N. Phenol now that has joined with N. H has gone, then carbon become negative, and that side Cl went as Cl minus, N is positive. Then N positive and carbon negative both joined. Then you will get long compound that is simply joined. All things are as it is. You will get para-hydroxy. Para because now OH came as a para position. Then para-hydroxy azobenzene. Para-hydroxy azobenzene. Two benzene rings are there. One due to the ArN2Cl. That benzene, other due to the phenol. Two benzene will come. In the middle, between the two benzene ring, N will come. N double bond. And both N is joined with two ring with one single bond. Correct? N is a double bond. Then both side benzene ring is there, and with the benzene ring OH is attached. Plus HCl you will get. Okay. Then this is called para-hydroxyazobenzene. This is the orange dye. This is called, color is orange. That is called orange dye. Another reaction, actually this is the coupling example of coupling reaction. Another coupling reaction I am telling you, also called electrophilic substitution reaction. Same way, that is a C6H5N2Cl plus aniline. In the place of OH now NH2 is there. That is the only difference. In the place of OH phenol, now it is aniline, NH2. Then same reaction will take place. H and Cl will react and it will go as HCl, and carbon will become negative, nitrogen become positive, both will join like previous reaction. Then now again long chain you will get. All things are same, only in the place of OH NH2 is there. Then you will get para-amino benzene. This is the yellow dye, yellow color. Question is asked, both questions are asked. Then you got yellow dye. Correct? That is called para-amino benzene. That was called para-hydroxybenzene due to the OH. Here due to the NH2, you are telling para-amino azobenzene. Azo you have to use because in the middle NN bond is there. That NN double bond is there. Now I am telling you some importance. Okay. Importance of diazonium salt in synthesis of aromatic compound. It is very useful compound. Diazonium salt is very useful in the synthesis of aromatic compounds. From this already I have discussed two reactions. From the above reaction, it is clear that the diazonium salts are very good intermediates for the introducing fluoride, chloride, bromide, iodide, CnOH, NO2 groups into the aromatic ring. I have discussed many reactions where chloride introduced, iodide introduced, fluoride, bromide, cyanide, all introduced. Okay, that's why by seeing these reactions, it is clear that and these other two reactions, above two reactions, what I discussed now, that the diazonium salts are very good intermediates for introduction of fluoride, chloride, bromide, iodide, cyanide, OH, NO2 group into the aromatic ring. Aryl fluoride and iodide cannot be prepared by direct halogenation. The cyano group cannot be introduced by nucleophilic substitution of chlorine in chlorobenzene, but cyanobenzene can easily be obtained from diazonium salt. Thus, the replacement of diazo group by other group is helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in benzene or substituted benzene. Okay, then I have discussed all the important things. One problem is there that I want to discuss before finishing this chapter. That is that this type of question actually is asked. Then it is actually conversion. Question I am telling you, how will you convert 4-nitrotoluene to 2-bromobenzoic acid? Means how will you get 2-bromobenzoic acid from 4-nitrotoluene? Very easy question. From 2-bromobenzoic acid means how will you get 2-bromobenzoic acid from 4-nitrotoluene? 4 means para. Then now explanation I am telling you, that is it is given 4-nitrotoluene. Toluene means with benzene ring CH3 is attached and NO2 is attached at para position. That is the carbon number 4 from the methyl group. Then how will you get 2-bromobenzoic acid? Then easily you can do. Here CH3 group actually will convert to COOH group, carboxylic group. Correct? Then that's why you will tell benzoic acid. Now see, first you do bromination, reaction with Br2. Then what will happen? That from you know that in in toluene, 4-nitrotoluene, other carbon has all 4 carbons now have hydrogen. That hydrogen will react with bromine. Then it will go as HBr. Then that HBr, Br2 will break into Br plus Br minus. Then Br minus will go with H plus as HBr. Correct? And Br plus will join with carbon negative. Carbon negative means bromine is introduced to the ring. Now after that you have to do these things, hydrogenation, reduction in presence of SnHCl, reduction. Then what you will get, actually Br is introduced. What you are getting 2-bromobenzoic acid, then at carbon number 2 bromine you have introduced. Now we have to think for the how will you get carboxylic acid. Then methyl group is there, CH3. That you have to convert to the carboxylic group. For that now third step, second step we got bromine introduced. Correct? Now again you are next step, reduction you are doing SN with SN HCl in the presence of SN and HCl. Then what will happen? Because reduction you are doing, then NO2 is there. Then NO2 you can convert to H2 because SnHCl in the presence of SnHCl, that NO2, that oxygen will go and at its place hydrogen will come. O2 will go as H2O, water, and O2 will go, then in its place hydrogen will join. It will form NH2. Then NO2 converted to NH2. Now next step, fourth step, now you do reaction with NaNO2 in presence of HCl. Temperature you have to maintain 273 to 278 Kelvin. Then here what will happen, that here NH2, actually you want to remove NH2. For that purpose you are doing all the things. Then NaNO2, now further reaction is with NaNO2 and HCl. Temperature you are maintaining less temperature, around 4 degrees Celsius, or you can tell 278 Kelvin, 5 degree, just around 5 degree you are maintaining low temperature. Then NH2, that NH2, this is the condition you just to remember, already I have discussed, that aniline in presence of NaNO2 and HCl and at low temperature, what will happen? It will form N2Cl. Azo diazo group will be introduced. NH2 will convert to N2Cl. Because NaNO2, Na will go as a Na plus, NO2 will be minus. Then that, and also HCl is there. Then that NH2, that H2 will go as water, and N will join with another N of NO2. Then now 2N joined, N2 you got, and oxygen again it will go. Oxygen again it will go as H2O, and because HCl is there, that is providing hydrogen. Then this N you will get N2Cl, diazonium salt you got, N2Cl. Now after that you do hydrolysis. Now you got this thing, N2Cl. Then on already discussed the reaction in presence of H3PO2, phosphorus acid, hypophosphorus acid, then this N2Cl actually will react with CH3, N2Cl will react with H2O in presence of H3PO2. Then what will happen? This CH3 that will convert to COOH. Correct? Then how many, this oxygen how came, from where it came? Then it came from the H3PO2, and one OH group has come from the H2O because you are doing hydrolysis. Then now methyl group converted to carboxylic acid after the oxidation, because you will get when you will do treatment, you will do with H3PO2 in presence of H2O, then this N2Cl will go and you will get that this is with benzene ring CH3 and Br will be there, carbon number 2, Br will be there, N2Cl gone. Then now after oxidation in presence of KMNO4 and NOH, OH is there, and KMNO4 will supply oxygen. Correct? Then now this CH3 will convert to C double OH. OH will come from the NOH. Correct? And oxygen will be introduced by, supplied by KMnO4. Hence you will get carboxylic acid. And at carbon number 2, bromine is there. That's why you got 2-bromobenzoic acid. This is a long actually, but question will be asked only 2 step. It is 5. That is a 6 step. 6 step, but in examination so long it will not ask. It will ask only maximum 3 step. Okay, part by part can be asked. So now I have finished the amine chapters. Now next class I will start new chapter. Thank you.